Hello, you're welcome. In this video, we are going to be looking at how we can use the series sum function of Excel to perform power series summation effectively. So this helps us to avoid the mistakes that we can make when we use the manual formula for this kind of calculation. So on my screen, you can see I have information for companies as well as algebraic expressions. Now, from these algebraic expressions, we have been able to ascertain that our x value is 3 for the first one, the second is 1.5, 2.5 for the third, and 4 for the fourth. Now, when we want to use manual method to perform calculations for these algebraic expressions, substituting the x values for each of these, you notice that this is going to consume a lot of time and effort, and this is even error prone. So to be able to avoid this kind of issues, we now use the series sum function of Excel. So for the manual function, we are going to look at it and see the result that we are able to get, and then now use the series sum function to see how we can make this work more efficient. So for this expression, 2x plus 3x squared plus 4x cubed and then plus 5x to the power of 4, if we are substituting 3 for x value, this is the manual formula that we are going to be using. 2 times the x plus 3 times the x to the power of 2 plus 4 times the x to the power of 3 plus 5 times x to the power of 4. And you see that this is a lot. It takes a lot of effort to be able to impute this. It takes time and it is prone to error. So let's just copy the formula and have it give us the results in cell H2. So we do same for H3. And do same for H4. So I don't want to manually type this because it's going to take a lot of time for us. So that's why I'm just copying the formulas. So these are the results we get when we use the manual formula to perform our calculation. Now, if we want to use the series sum function, there are arguments that we need. So if I enter series sum, for example, the first argument is x, and this x is the input value for x. Okay, so it is what we say x is. In this case, it is 3. In this other case, it is 1.5. Then the n argument is the initial power. So you can see the initial power we have here is 1. Okay, in the second one, it is 2. In the second one, it is 0. In the third one, it is 2. Then the m is actually the step size. So you can see from 1 we get 2, from 2 we get 3. It tells us that our step size in this very case is 1. In the second one, you see from 2 we get 3, we get 4, and we get 5. It still tells us that our step size is 1. Now, for this very one, we are starting from 0, and then we are getting 2, and then getting 4, and getting 6, which shows us that the step size is 2. For the last one, we start with 2, and then 1, and then 0, which tells us that our step size is -1. Then the last argument that we need is the coefficients. So the coefficient is just the coefficients of this algebraic expression, where we have 2, 3, 4, and 5. So we are going to have this expressed as arrays when we want to add it to this very function. So we enter it as arrays. So 2 as an array, comma 3, comma 4, comma 5. And then we now enter it as the coefficient. So let's see how this works in practice and see if it eventually gives us the result we have from this manual calculation. So I will enter series sum, then enter my x, enter my n, and enter my step, okay, which is the m. Now for the coefficient, I'm going to manually enter it. So which is 2, 3, 4, and 5. So you see that we get exactly the same result as the manual calculation, but this is faster. So we still use the series sum function. We get our x, get our n, get our m, and then enter our array, which is 1, 2, 3, and 4. And we get exactly the same result as what we have for the manual, but this is still faster than the manual and reduces the risk of error for us. So let's try the second to the last. So select x, n, m, then let's enter our arrays, 6, 4, 2, 1. And we have exactly the same result as we initially got for the manual calculation. And finally, we use the series sum to check for x, n, m, then enter our coefficients, 3, 2, 1, 0.5. And you see that we still have the same result as we will get when we use the manual calculation. However, this reduces the effort of typing all this, as well as helping us reduce the risk of error during the course of this calculation. And this is just what I want to demonstrate to you in this video about how we can use the power series summation function, that is the series sum function of Excel, in order to effectively perform power series summation. I hope you've been able to find this video helpful. Please, if you have, kindly like, share, and subscribe to our channel. Thank you, and I'll see you in the next one.